Yeah, comes on everyone. Let's start off. Sure. So last thing we are doing this cavity ka thing. The next thing, aerial expansion. So we define something called beta, which is coefficient of aerial expansion. So let's say you have a material. This side is length L1. Quotient of linear expansion is alpha 1. This is beta alpha 2. So you can have materials, which expand differently in different directions also. So when you increase the temperature or decrease the temperature, this guy becomes L into 1 plus alpha 1 delta T. This guy becomes B into 1 plus alpha 2 delta T. So basically we choose these are called as anisotropic materials. Isotropic meaning uniform, anisotropic is non-uniform. Ali, Adrit, camps on. So if you take the change in area here, that will be the final area minus initial area. That will be LB 1 plus alpha 1 delta T 1 plus alpha 2 delta T minus LB. So when you expand this, LB ka term will cancel off. This gets cancelled. This is neglected. So you end up with area is LD, that is the old area, into 1 plus alpha 1 plus alpha 2 delta T. One. So here what we write? So we can simply write change in area is area into beta delta T, where beta is given by alpha 1 plus alpha 2. This is your coefficient of aerial expansion. So beta can be also done as change in area per unit temperature per unit area. If the material is isotropic, that is alpha 1 becomes alpha 2, then beta is 2 alpha. Have a look at this. Not really that great thing, but yeah. This is all happening because you're ignoring the higher power terms. Looks like a major test results are out. Do send me your marks. Individual subject wise. Mains, advanced, maths, physics, chemistry, all three subjects. That will be useful. Not only PACE people, even people from other institutes, right? Whatever exams happen, if you can send me your marks, that will be good. Because if you're goofing up something, at least you'll get someone to scold you. And that's important. Okay, once it comes, you send it, not an issue. Clear? Next one.
So can you go
The
back
one.
to the menu?
Hmm. God, Udayan, why are you late?
Yes, no thank you.
That's why I enabled waiting room. I want to see who is coming late. Classes at 5:30. Try to be on time. If you miss out on things, then you won't understand. Next thing. Volume expansion. Here we define something as gamma, which is coefficient of volume expansion. So this happens in 3D. Let's say this is L1, alpha 1, L2, alpha 2, L3, alpha 3. Or I can take it as B and H also. H, alpha 3, this is B, alpha 2. So now again, same story here, the change in volume. So V final will be LVH, 1 plus alpha 1 delta T, 1 plus alpha 2 delta T, 1 plus alpha 3 delta T. So this would be initial volume into 1 plus alpha 1 plus alpha 2 plus alpha 3 delta T. We neglect the higher terms. You can do this because alpha is quite small. The you end up with V alpha is V into 1 plus gamma delta T. More than delta beta, na, gamma is quite important. So here gamma is alpha 1 plus alpha 2 plus alpha 3. If alpha 1 is equal to alpha 2 is equal to alpha 3, then gamma becomes equal to 3 alpha. These kind of dumb questions did come in CET. They said alpha 1 is equal to alpha 2 is equal to alpha 3 is 2 times alpha 1. And then said find, gamma. People were confused, like, because everyone just mugged up gamma is 3 alpha. So gamma is simply 1 by volume dV by dt. This is useful, right? Because volume expansion, right? You can use this for liquids and gases also. Because beta and alpha are not defined for liquids and gases. That's why volume expansion is more important. Because for liquids and gases, there is no meaning of length and area. Only gamma is defined for them. Have a look at this. Can I go ahead? Next thing. Now, when you write for this for liquids, See, this happens. For leakage, especially the issue is this. Palak, why are you late? Until unless we call you to your house and then we remind you guys won't join or something. There is some issue, you guys at least should, have some courtesy to message like so and so I'm not able to come on time. Yeah, can't do anything. That is not an excuse, right? That is just being, clear details not being, there's no dedication, nothing much. Anyways, I keep telling you guys this thing. What is the most important thing is your dedication and consistency. You might think like, sir, एक चीज में क्या हो जाएगा? Problem वही है. Once you start, you don't stop. You'll have an excuse for every damn thing. You know how most people start smoking and drinking? Because one idiot friend will come and say, अरे एक बार try करके देखना. You will say no. अरे कुछ नहीं होगा एक बार ना. If you don't like, तो don't do it. वो एक बार भी नहीं करना है. It starts like that. That is, because you're putting a precedent. You're saying if there is an issue, I can give an excuse. And once you start learning to give an excuse, you taught your brain something bad. कुछ भी हुआ, I have an excuse. Homework क्यों नहीं किया? मुझे headache आ रहा है. Okay, headache आ रहा है. So, did you stop watching your phone? Did you actually sleep for 24 hours when you have a headache? No, but you want a damn excuse not to do your homework. Right? Sir, my subject is bad. Rotation नहीं अच्छे से हो रहा है. Okay, did you finish off HCV? Did you finish off, whatever your booklet? Did you do at least 200 questions? नहीं, sir. क्यों? Actually, last week marriage जाना था. Last week वो था, ये था. Sheer lack of commitment. Getting it? It is not your IQ. Most people think, it is, I'm not understanding and all. It is just lack of commitment और कुछ नहीं है. I'm seeing with your seniors now, no? People are getting scared one day before the exam. They shit scared. They call me, they're crying, sir, ऐसा है, ऐसा है. Lack of commitment और कुछ नहीं है. You might think एक दिन में क्या होगा? वो एक दिन, right? It starts. It is just like eating that Lay's and ice cream. You just can't stop with one scoop or one chip or one chocolate. Keep this in mind. You're really serious about cracking the exam? Forget about the exam. You want to do anything in life going ahead, you need dedication and consistency. Commitment. और कुछ नहीं. If you can stay awake till morning 4 o'clock and watch a movie, if you can stay awake till morning 4 o'clock and watch a football match, you can stay awake till 4 o'clock and study also. I know that is not a big deal, staying till 4 o'clock, because I know some of you do. But वो कैसा करते हैं आप लोग? You start studying at 12 o'clock and you study till 4 o'clock. This is bullshit. This is bullshit. This is not consistency. That is sheer lack of planning. And some of you stopped sending reports. Clearly tells you. Because if you send a report, I get nothing. It is actually unnecessarily hard work for me. But I still keep insisting you to send a report. Not for me, for your guys, for your sake. Some of you don't care. Just shows how committed you are. Or nothing much. What to do? You thought you guys think I got into IIT because I was very smart and intelligent and all bullshit. I was always in somewhere in 20 to 30 ka beech mein in the class. I didn't give a damn about what others thought about me. I just kept working. I used to score less. I used to score very bad. 84 में I used to score 12, 13, 14, 20s में आता था physics में. I only used to think of one thing. Something I goofed up. Let me go and learn. Come back again, put a fight. Come back again, put a fight. Why do you think I keep putting so many tests every week for you guys? Because of the test, at least you'll open the book. And because after writing the paper, you'll resolve the paper. So indirectly, I'm making you practice a lot of physics questions without you knowing. But some of you feel like, अरे सर every week का test बहुत stressful हो रहा है. 1 hour का test आपको stressful हो रहा है. सर बाकी भी करना है. Welcome to life. So tomorrow, when you are, when you're grown up in life, do you just want good health but no wealth, bad family, just want only one thing? No, na. In life, you want everything to be good. Then you have to do everything. You have to manage. You're not able to manage, then you need to talk to teachers. You need to take some guidance. Abhi aise aisa ho raha hai. What do you think? Morning, I sent a thing in the group. Dekha? Keep watching that. Keep seeing that. You'll understand. That's it. That is the whole point. So what's density here? We know density is mass by volume. Now, if you're talking about a new density, whenever you change temperature, mass remains same, but what changes is volume. Because next year, this time, you guys will be writing the JEE mains exam. I don't want these kind of, crying and all from the way your seniors were. Some of them started becoming serious in the last 6 months and started studying. They couldn't handle it. It was too much for them. Please don't do that. You still have 1 year time. Start working. Take things seriously from now. You're not dedicated. You're not consistent. You find excuses for every damn thing to skip a work. एक दिन 2 दिन ऐसा लगता है, but this will mess up. Maybe your potential was to get a rank of 3,000. Getting it? You don't do it, it'll become 30,000. Maybe if you just chill out little more, maybe this might become 6,000. This might become 9,000 or 13,000. If you have to push yourself to maintain even that 3,000 first of all. And then if you keep doing, maybe one day this might go to 1,000. Who knows? If someone here is under an illusion like 1,000 rank बहुत easily हो जाएगा, you guys are for a very rough ride going ahead. So please keep working. I'm telling you again, you all have enough IQ. IQ का problem ही नहीं है. Capability ना, there are thousands of people on the road with capability. क्या करना है उससे? Dedication नहीं है, consistency नहीं है. You mess up one exam, you start panicking like rats. Oh, exam, 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 exam. You're not bothered like, boss, exactly wrong क्या हो रहा है? Instead of focusing on that, you're only bothered about marks, marks. I'm not saying nothing wrong with that. That also I won't feel bad. But you guys call and say, you know what? Sir, मैं इतना काम करने के बाद भी मेरा friends को ज़्यादा marks आया. Then I feel like slapping you actually. You should have said me, sir, I worked hard, but I didn't perform up to what I thought. So how should I improve? ये अलग होता है. But 90% of the people, first thing they say is, sir, my friends got more than me. Bloody, why the hell are you comparing your life with some idiot? You don't stop doing that, you'll just make your life more miserable. Dedication मतलब कुछ ज्यादा नहीं है रे. नहीं, I told you, some of you had a problem with the phone. I told you to don't use the phone after the PTM. Ask yourself, how many of you did that actually? How many of you are actually using a Nokia mobile phone? Left the smartphone completely. How many of you are actually putting work? Ask yourself. How many of you are still wasting your time on social media? It could be anything. Instagram, YouTube, kuch bhi. Every day, let's say you're going in a car to the class. I told this to some people. They are traveling almost 40 minutes every day in a car one way and coming back 40 minutes one way. I said 40 minutes in a car, you're traveling in a car, right? Why don't you take your notes and revise and study there? You guys feel like, oh, it looks so nerdish. Nerdish kya hota hai? People think you're weird. Let it be. End of the day, you're going to get a result. If you're not being weird, then something wrong with you. You're not going to achieve anything. If you go to IIT bloody, you'll find half of the idiots are weird there. They do things you can't imagine. You're sitting and studying, night 12:30, you're feeling sleepy. What do? You know what I used to do? I used to do 20 push-ups. Then I used to start studying. Right? Because कल homework submit करना है. कल you have to do the work, not because sir is asking. मुझे करना है. मेरा commitment है. Because once you start breaking your own words, you'll stop respecting yourself. And once you don't have self-respect, no matter what you want to do in life, right, tomorrow you won't have confidence because you won't even trust your own words like, can I do this? And when you don't trust yourself, it reflects on your face. The other guy in front of you won't trust you. And that could be anything. It could be a personal life, it could be a professional life, it could be anything. Tomorrow, when you go and tell your mom, I'm planning to start a company, she will laugh at you first. And that's an insult. The parent who was there with you for like 17, 18 years, who saw you growing, laughs at you when you say start a company. Instead of thinking, oh, such a big thing, difficult but try karo, ये अलग होता है. But your mom starts laughing at you. तू तेरा खुद का रूम साफ नहीं कर सकता तो कंपनी चलाओगे. That is the kind of perception you have created in your parents' mind about you. And then you think like, oh, my parents are not supporting me. That's the problem. So all I'm asking is, please put work, be dedicated, not for me, not for your parents, but for your own self-respect and self-esteem. Don't do it for your bloody friends. Don't do it to compare with someone. Today you're scoring 150 out of 300. You target for 180. Sir, but my friend got 300 out of 300. Let him die. That is not your problem. You got 180. You aim for 200. You got 210. You're the first rank in the class. You're first rank all over Mumbai. It doesn't matter. You aim for 240. You continue working. You keep progressing. You are your own competition. You are your own enemy. You are your own friend. The best friend you have is yourself. Don't cheat him or her. Because next year I don't want you guys to call me and cry like, sir, मुझे अभी समझ में नहीं आ रहा मैं क्या करूं. I'm scared. There is one idiot who didn't give the exam. पता है. Close the door, sat inside and like मुझे exam नहीं देना, मुझे डर लग रहा है. Parent calls crying and said, sir, मैं क्या करूं? I said like, मैम छोड़ दो अभी. No point. He won't listen. अभी और कुछ extra बोलेंगे. I'm scared. He might do something to himself. Didn't write the exam. Now he can't call me and talk to me. He can't face me. I want to call. I don't know how he will react. Nothing, right? You go stand in front of the mirror and look at yourself, right? Ask yourself, like, boss, do I have the confidence? And there'll be an answer. And see, सबको लगता है confidence मतलब it is not about your words. The amount of work you have done, the amount of things you have done over a span of time, those achievements, right, are like a proof, which will say like, boss, तू कर सकते हो. When you are not disciplined, when you don't do things every day consistently without dedication, how will you trust even yourself? इसीलिए confidence नहीं आता है. Tell me one thing. Let's say I told all your seniors to write almost 30 full syllabus mains papers. 30 full syllabus mains papers. 3 hours ka. There are some people who wrote two papers in a day for a week. You know why? Just to complete the quota. 30 papers complete करने के लिए अगर एक दिन भी लिखेंगे तो 1 month हो जाएगा ना. तो some people decided to write two papers in a day so that जल्दी खत्म कर सकते हैं. Because उनका chemistry revise करना था. Now see, that is a way to do. What some people did, sir, हमको chemistry revise करना था, इतना papers कैसे होगा? Can we do discount 15 papers लिख सकते हैं? I said करो, अभी fine. 15 papers लिखा, उसमें 5-6 papers marks अच्छे से नहीं आया, 5-6 papers seriously नहीं दिया. Last में अभी last 5 papers you got scared, you didn't give them only. You're not dedicated. You had an excuse for everything. मेरा revision नहीं हुआ, वो हुआ, ये हुआ. And these are the people who started panicking in the end. But imagine the other way around. The people who give 30 papers, right? Imagine if you're scoring in every test 180, 190, 175, 200, 185, 200. Your scores are in the range of 180 to 220. One day before the exam, when you're getting scared, if I tell you, अरे यार, according to your performance, I'm sure you'll still at least score 170 to 180 का ऊपर आएगा. Will you trust me? More than you trusting me, you will accept it because I gave almost 20 tests and sub में 180 पे ऊपर था. Now with that confidence, you'll be able to sleep in the night. But imagine a guy who wrote 10 tests. First 3-4 tests, he scored 120s and 130s. Last 4 5 tests, right? He wrote for 1 hour, he got up, paper बाद में आके थोड़ा time लिखा, he wrote for 3.5 hours, कुछ भी किया. There was no consistency only in the way you write. These are the guys who will panic. And उसको कैसा convince करेंगे? Boss, everything is fine, please go to the exam. Confidence is nothing but, the proof that you have done your work and you're dedicated over a span of time. That events are what is the confidence. Nothing much. It's like me asking, how many of you are sure if you keep a vectors ka test in next 10 minutes, you'll be able to write? थोड़ा confident है ना? Because practice किया था. Starting chapter था, easy था, practice किया था. But same thing if I said about rotational mechanics. वो भी फिर भी I'm sure some of you must have done work. So you feel like, हाँ sir, I can try. It's all about that. Think about it. The last time when you did a lot of work, you did well in the test. When you didn't do work, you messed up. Simple. So don't expect some big tricks and all. कुछ नहीं है. Consistent, everyday consistent work. Chalo, we'll get back. Please think about that. I'm telling you, it is very stressful, talking to your seniors. People crying and all. Yeah, last 1 week had been a weird thing for me. People, before going the test, they call and cry. After that, messing up the test, they call and cry. It's very stressful. मतलब, I feel bad for the parents and the kid. अभी क्या कर सकते हैं? You guys have 1 year time. Figure out. Become strong. Because in the exam, there'll be no one to come and support you except yourself. Be so strong that you should be able to console yourself. So this is the formula there. So density, right? Whenever you increase the temperature, this is what happens. As such, in this chapter, we don't have really good problems on this, but in fluid mechanics, we'll do a lot. So generally, whenever you increase the temperature, the density decreases. But there is an exception here. Anomalous expansion of water. When you take density of water with respect to temperature, at 4 degrees, you have maximum density. I hope you studied in this thing. Chemistry, remember anomalous expansion? Basically, when it starts becoming ice, it starts forming an hexagonal ice structures. So air molecules are trapped inside. So ice is like the special structure where a solid is actually less denser than the liquid. That's the reason ice floats. At 4 degrees, water has maximum density. One of the reason why, in cold countries, the fish don't die in winter. Think about it. Let's say the summer to winter is slowly approaching and the temperature drops to -10, -20. So on the top of the lake, when the water reaches 4 degrees, the water starts sinking. So outside the temperature is -10 degrees, but at the bottom of the lake, the temperature is 4 degrees. Isn't it? All the denser water will sink. So the fish are living at the bottom of the lake at 4 degrees, whereas the outside temperature is actually -10 degrees. So it starts freezing. And because ice is a less denser, ice starts floating. And ice is a bad conductor. So more and more ice forms, it becomes more and more difficult to heat to escape outside. We'll see a problem always in heat transfer. So by the time the entire lake freezes, it will be taking years. By the time new summer will come, ice will melt and fish are back again. So this property is actually, what make sure that aquatic life is alive during winters. Nahi to whenever there is an ice age, the entire sea life would have been dead. The entire oceans would have been frozen. And density of ice is 0.9 gram per cc. Do remember these results. This also happened. There are few results I told people to remember and go. And this idiot thought like, nahi, nahi, sir, wo denge na karke, forgot. And that exact same question came. He got physics में 90. He messed up that one question. So Results are important. Have a look at this.
So results as in the values, right?
Which one?
Like the values, right? The density values.
Values. Yeah.
Okay.
Clear? Let's show you a question on this. Let's say we have a container filled with 4 degrees water. Now, if I increase or decrease the temperature, in which case will the water overflow? If temperature increases or decreases, in which case will the water overflow? Think properly, na. Fast answers don't get marks. You get marks for right answers.
Decrease.
Okay. Previous page here. And type the answers in your chat box. We do have few answers. Okay. Adrit, Anusha, you are right. Remaining, all of you got it wrong. See what happens. Now, when you increase or decrease the temperature in both the cases, what happens? Density decreases. That means volume will increase. So water overflows now. Because at 4 degrees, it is maximum. So if temperature is increased or decreased, density decreases. If density decreases, volume increases. So it overflows in both the cases. Clear? And same thing, let's say this, just be careful. This is quite useful later on. If you have an ice cube of side A, right? And if this melts into water, what remains same here is mass of ice will be equal to mass of water. So mass of ice will be density of ice, that is 0.9 a cube, and density of water will be 1 into volume of water. So if this volume is a cube, this will be only 0.9 a cube. So be careful with this. So whenever the ice melts, you actually get less water. Mass will remain same, but water will become less. Clear? So basically in both the cases, it does overflow. Any doubts on this? Can I go ahead? Aryan, clear now? Yeah. Next thing, apparent expansion. What is this apparent expansion? Now, the problem with the liquids, right? Whenever you heat them, you always heat them in a container. And because when you heat a container, it also expands. So this thing gives you a error. When a liquid is heated, the container also expands, which gives us an error. So now actually when you're heating something, right, the liquid content both will expand at the same time. But let me show you, let's assume it happens one at a time and see what happens actually. Let's say we have a water level at 100. So let only container expand. Now, if the container only expands, now it will think the liquid level has dropped. Agreed? Water is same, container has become bigger, so the readings will look less. Now let liquid expand. Now if liquid also starts expanding, let's say the reading becomes 110. Now you tell me, what is the actual expansion? The liquid actually expanded from where to where? The actual expansion is 110 minus 95, right? But when you see this, actually this stage does not occur. You directly go from here to here. When you're heating, what you see is directly you go from 100 to 110. So you start thinking the liquid expanded only 10 units. So the apparent expansion you think is 110 minus 100. This is 10. Get the catch? Because the container expanded, this starts creating an error. So we have something called an apparent expansion. Apparent expansion meaning expansion with respect to container. So we can write the formula like this. Apparent expansion is real expansion minus container of expansion of container. So V gamma apparent delta T. This is V gamma real delta T minus V for a container gamma is 3 alpha. This is gamma of container. For solids, gamma is 3 alpha. For liquids, there is no alpha and beta. It is only just gamma only. So V gets cancelled off. We end up with gamma apparent is gamma real minus 3 alpha. Z. So the meaning of this is, for example, if gamma real is equal to 3 alpha, no matter how much you heat, you think the liquid level does not rise. It will always show that same 100 reading. Have a look at this. We'll do a question based on that. It will be a good matrix matching though. Any doubts on this page? Please have a look at this. Clear? Can I go ahead? Ali, clear na? Palaksh? Clear? Neil? Vidyut? Vartika? Perfect. Next one. So let's say we have a container. V is the volume, Vc is the volume of container. VL is the volume of the liquid. Alpha is the coefficient of linear expansion of container. Gamma is the coefficient of volume expansion of liquid. Great. So the simple question, find the condition if the empty volume of the empty space always remains constant. Let's say if you're heating the liquid, container will expand, liquid will expand, but that empty space ka jo volume tha, that should remain same. If volume of empty space remains constant. At any temperature. Means whether you increase the temperature or decrease the temperature, let the liquid change, let the container change, but let the empty space remain same. Try, got a minute. So what is empty space? So initially empty space, let's call it E, which is nothing but volume of container minus volume of liquid. Now you're saying when you change this thing, this should still remain same. So this will be Vc into 1 plus 3 alpha delta T. This is the new volume of the container. Minus V liquid 1 plus gamma delta T. This is the new liquid of container. This should be equal to still Vc minus VL. So you end up with Vc3 alpha minus VL gamma is equal to 0. Easy. 3 Vc alpha is equal to gamma VL. बस इतना ही करना था. Clear? Let's assume the temperature changes by delta T. Find the new container volume. Find the new liquid volume. The difference should be equal to the initial difference. That's it. There's nothing there. It's an easy one. Mostly mains maybe easy level question this is. Next one is a good one. Let's see. Clear? Next one. We have a container filled with some markings. So we have scale also here, 0, like 1. So there is a scale on top of this. And the height of the liquid is h. The base area in cylindrical container, base area is A. The actual height I don't know. Cylinder ka actual height is not given. Container ka is alpha C. Liquid is gamma. Gamma is the volume expansion of liquid and alpha C is for the container. Linear expansion. Now, find the height of the liquid as measured with the ground frame. If you're standing on the ground frame and you're measuring, what is the height of the liquid? But if you ask the container only to measure, now understand container ka scale is also messed up, isn't it? When you're actually measuring from the ground frame, you'll use a proper scale, liquid expanded. But if you measure with respect to the container ka scale is also messed up, as measured by the scale of the container. When temperature changes by delta T. Let's get this. So
The
exam question is
container only expanding linearly, right?
which one?
The container is expanding only linearly, right?
Why?
You gave only achha, oh, okay, fine. Sorry, my bad.
So can
Exam
you-
will ask a question like this, like Abhinav?
Can you show the previous ones for a second?
This one.
Yes, sir. Thank you.
Exam question is find the condition if the height of the liquid in the ground frame is always same. Find the condition so that the liquid overflows. So you can ask multiple things. Let's get this. Then we will see all those cases. Ooh, HA alpha T, what is that? Your dimensions are not matching, God. Adret. Dimensions match नहीं हो रहे थे ना? No, but still, no, dimensions are not matching. How did you multiply h into area? H into 1 plus gamma plus no, Anika, that is wrong. Let's see. Okay. First, let's do this thing. Problem is container liquid are expanding differently. So first take out the liquid. What is the volume of the liquid? Area into height h. That's your initial volume. Now, when you change the temperature, the liquid expands and the new volume becomes AH into 1 plus gamma delta T. Agreed? This is the actual volume. Now, you took this container, the new base area will become A into 1 plus 2 alpha delta T. Area depends only on 2 alpha. And now you took this liquid and poured it in this. So when you took this liquid and you dumped into this container with a new base area, I agree, height also increased, but that time not interested here, and let this new height be h dash. So from volume conservation, so the liquid dropped AH into 1 plus gamma delta T should be equal to the new base area, which is A into 1 plus 2 alpha delta T into h nu. Therefore, the new height of the liquid will be h into 1 plus gamma delta T by 1 plus 2 alpha delta T. Now, if you want, you can do a binomial approximation here. 1 plus gamma delta T, 1 plus 2 alpha delta T whole power minus 1. This becomes h into 1 plus gamma minus 2 alpha delta T. So if gamma is equal to 2 alpha, the height now does change. Anusha, you got that. Ali, yeah. Do have a look at this. This is the actual height. This is the actual height as seen from the ground. Now, what about that scale? If you remember, there was a formula we did for scales. The reading of a scale will be the actual height by the factor the scale increased. Reading of scale will be h nu by 1 plus alpha delta t. Agreed? Because the scale has increased by a factor of 1 plus alpha delta t. So this would become h into 1 plus gamma delta t by 1 plus 2 alpha delta t, 1 plus alpha delta t, which is actually can write as 3 alpha. And if you use binomial approximation, you get h into 1 plus gamma minus 3 alpha delta t. So this is an apparent height. Scale will show this reading. In the ground frame, the actual height is this. Now here, because the scale itself got expanded, Mr. Tom and h nu, what did I miss?
सर वो जो एच है वो जो हमने निकाला वही डालना है ना
ये ना Where you're saying reading of scale में I kept this thing, I didn't keep this.
Oh, अच्छा.
Same ही आएगा, मतलब end में उसी if you do binomial approximation you'll end up with this only.
हाँ सर ठीक.
Got it? Now let's see what is the meaning of this. Please have a look at this page. So if you use the scale on the container, it will show something else, because scale also expanded, you'll get even lesser reading. The liquid actually must have gone higher, but the scale will still show something lesser. Now, let me show you with some examples that will give you a better understanding exactly what's happening. But everyone clear with this page? Clear? Now, listen. Let's say gamma is less than 2 alpha. This will be a matrix matching equation. Let's understand what does that mean. So let's say we have a container, and let's say the container is showing reading 100. Now, when you increase the temperature, now see what happens. If gamma is less than 2 alpha, the actual height also decreases. When the container is expanding so much, it feels as if the liquid level has decreased. So this is what you will notice. The actual height decreased. On top of it, the container also will show reading as 90. So if gamma is less than 2 alpha, the actual height decreases. And reading of the scale also decreases. Initially it was 100, it will be less now. If suppose gamma is exactly 2 alpha, initially it was 100, the level will be exactly same, but the container will show this thing as 95. The actual height is same, but because the scale got expanded, container thinks it is less than 100. Suppose if gamma is between 3 alpha but greater than 2 alpha, the actual height increases. Let's say this is 100. The container will still show maybe 98. The actual height increased, but the container still shows the height is less. If gamma is 3 alpha, the actual height increased. Now container will also show 100. समझ में आ रहा है? Gamma 3 alpha मतलब वो था. Apparent expansion is 0. Meaning container, with respect to container will never think the reading has changed. So here actual height increases, the reading of the scale remains same. So don't get confused between gamma 2 alpha. Actual height is different, apparent height is different. Actual height increases, reading is same. I hope the numbers are making sense. If gamma is greater than 3 alpha, if this is 100, maybe this is, let's say, 105. The actual height increased, reading also increased. So now you tell me, if the liquid has to overflow, which is a condition? Under what condition the liquid will overflow? It should come out of the container. This na gamma greater than 3 alpha. It should expand even more than the scale. If you take gamma 3 alpha, it will be the container always think you're at the same height. You will never overflow. So for gamma greater than 3 alpha, you will overflow. Again, think about it. Apparent expansion with respect to container. If that is greater, means what? You are expanding more than the container and you can overflow. Please have a look at this page. It's a pretty good one. This thing will be like a matrix matching. On the left hand side, they'll give you gamma is equal to 1.5 alpha, gamma is equal to 2 alpha, gamma is equal to 2.5 alpha, gamma is 3 alpha, 3.5, and they'll give you options here. Height increases, decreases, volume increases, decreases, blah, blah, blah. Then you have to match them. So you can frame a question like that on this. Most people, they just remember gamma 3 alpha. No problem. They just remember this result and they try to apply this everywhere. Gamma is 3 alpha, gamma is 3 alpha, but that is apparent. Clear? Next thing. So that is about thermal expansion. Now, in this, actually, there are some models, but those are actually based on, Young's modulus and elasticity. So we will do those questions there. And there are some questions based on fluid mechanics also. So when that respective chapter comes, we will do it there. We will not mix it up here. So this is one part, thermal expansion. The second one is calorimetry. This is like your school stuff, what you did. So there's a bit of a theory. Let's see. Turning the page. Everyone clear with this? So what's calorimetry? It deals with relation between temperature and heat. Then we define something called a calorie. So the calorie is the amount of heat required to change temperature of 1 gram of water from 14.5 Celsius to 15.5 Celsius. Experimented, that is the thing, but generally we take for any 1 degree, it is 1 calorie. Then we have something called mechanical joule equivalent. The word looks big and all, but it's nothing. what happened now? The story was like this. Initially, when people were working on, this heat, so people thought in order to increase the temperature, we need to give something called heat. People thought like, work cannot increase temperature. For example, if you put your hands both together and if you rub them, won't they become warm? Right. So you're not giving any heat there, isn't it? What you're giving is work. So initially, like when the experiments are doing, people thought you can change temperature only when you give heat. But later on, people realized, no, that is not the scenario. You can actually give even work also and change the temperature. Then they said, oh shit, that means you're talking about the same thing. It's not a new thing. So we had to convert all the factors, of heat into joules. So mechanical joule equivalent is simply a conversion factor from calories to joule. That is because initially people thought heat and work are different. Heat and energy are different. So whenever you hear this word mechanical joule equivalent is nothing. It's a conversion factor between calories and joules. So 1 calorie is 4.18 joules. Approximately we take it as 4.2 joules. So ever seen on the food ka packets mein they write it as kilojoules? It will be always in kilocalories. But actually they misuse the terms. They say how much is this food? 250 calories. It's actually 250 kilocalories. So everything that is mentioned on a food ka label is actually in kilocalories. So it is the same thing also. So when you are running and jumping, so think of like this. So let's say we have a person here, 80 kg person, right? And if he jumps 1 meter high and falls down, 1 meter high and falls down every second, how much energy is he actually consuming? M G H. That's how much? 800. That is what? Joules divided by approximately 4. That is how much? 200 calories. That is approximately 0.2 kilocalories. So every time this guy, so if you go and let's say let's say you drink a Coke, 200 ml Coke, right, is almost around, I think, 80, 100 calories hoga. Aram se. So you just have to jump how many times? 100 by 0.2, 500 times. Pass. You're getting it? So when people lose weight, this is what happens when you don't study properly. People don't analyze stuff. They just want to lose weight and they think, what, I can eat any shit. And then, you can start doing workout and exercise and you can lose weight. You can't lose weight by exercise. Mathematically, it's a very difficult thing. And human bodies are highly adaptable. They save energy like anything. So if you stop eating, reduce your food, that is another headache. But this is a story. You just eat your Cadbury full chocolate, that is almost 500 calories. Dairy Milk Silk, the big one. I think that is 600, I guess. Last time I ate one full thing, I was observing it. I took one piece. There are like 12 or something. Na? I took one strip. I said, चलो एक और लेते हैं. I said, ये last है. I said, अब इतना छोटा बच्चा क्या करेंगे? I just finished it. वो होता है, right? You feel like अब इतना छोटा भी क्यों छोड़ने? Let's complete it. There. And that's the best part. That Cadbury chocolate is there in the fridge from a long time, almost a month. The mistake is my wife, na? She opened it and took one piece. Did you ever observe this? If it is not open, it will be there, you're fine with it. But someone opens it and leaves it, then it is gone. So that is the problem. Anyways, so this is a mechanical joule equivalent there. Now, if you have a body here, let's say temperature is T, the temperature becomes T plus dt when heat dq is given. So we use dq is a small heat. Q is a symbol for heat that we are going to use. So when dq heat is given to the system, let temperature change by dt. So we can write dq is equal to ms dt. And after dq is proportional to dt and all that blah blah blah, I'm just directly dumping it. Where m is the mass of the body, s is the specific heat. So basically S tells you it is the amount of heat required per unit mass per unit temperature. The actual formula is this. dq is proportional to dt. So dq is equal to ms dt. So delta q will be integral ms dt. So if mass and S are also changing with temperature, you have to be careful. There. So you can put down this formula if you want. So this is your first formula in calorimetry. dq is equal to ms dt, or delta q is integral ms dt. So the specific heat capacity, right? Higher the value of this thing, higher the S, more difficult to change the temperature of the body. Means you need to give more heat in order to change the temperature. So let me ask you this question. Let's say you're trying to construct a thermometer with a new liquid. Instead of mercury, you want to create with a new liquid. So for the new liquid, which of the following options are right? The coefficient of volume expansion should be more, specific heat should be more, or volume expansion should be less, specific heat should be less. That is more, this is less, the less, is 4 options. Which of the following should be property of the liquid to be used in a liquid thermometer? Should alpha be more, expansion should be more, should S be more, or less? ऐसा 4 options होगा. Both are more, both are less. Alpha is more, gamma less. ऐसा. What do you guys think? If you want to use a liquid, I'll write that as an example. How to do?
The original question क्या था?
I'll write it on it. I'll turn the page. Let's say question is like this. A liquid is used in a thermometer. So it should have, right, this volume expansion should have this gamma. It should be more, or specific heat. This should be more, or both are less, or which is more and which is less. It should have what? More gamma or less gamma? Gamma is coefficient of volume expansion. It should have more S or less S. S is specific heat capacity. What do you guys think? Think about it. Let's say you're using this thing, right? Let's try to understand each one. Suppose if gamma is less, what is the meaning of this? Means this guy won't expand that easily. That means you need to provide more heat so that more temperature can change, so that more can expand. That means you have to keep on holding to the thermometer for a long time, isn't it? So you want the thermometer to work in a minute or in an half an hour? In a smaller time possible. So gamma should be more or less? Gamma should be more. It should have more gamma. So that liquid can expand much faster. What about S? Specific heat capacity. Should it be more or less? Again, think this way. If S is more, means what? I need to provide more heat for the temperature to change. And once temperature changes, then this will expand more. So you want it to want to easily change the temperature, or difficult to change the temperature? So when you touch it, shouldn't the temperature of the thermometer in your hand should become same as fast as possible? So specific heat should be less. Making sense? So you want a liquid which will take less heat and will change the temperature fast so that it can expand more. Then you can make a thermometer which is more sensitive. Even for small temperature changes, you will have a reading. Clear? So if you have these values, the thermometer will be more sensitive. What do you mean by sensitivity? Meaning how much you react even for small changes. That is it. Reading changes even for small values. Let's say the thermometer rate does not move until unless you have 1 degree ka change in temperature. You have a thermometer which changes for every 0.1 degree. The 0.1 degree is more sensitive. It's like someone comes and calls you, pig. You feel bad, you get hurt, and you cry. You're very sensitive. Someone comes and gives you full gali and calls you all nonsense things, and you're least bothered. You're not sensitive. We say, na, this person is very sensitive. You say small thing and they feel bad. Same thing. Instruments also the same thing. Sensitivity. So it is that. And there are a few values you need to remember here. Specific heat of water is 1 calorie per gram per Celsius. Specific heat of ice and specific heat of steam is half calorie per gram per Celsius. Means for every 1 gram to change temperature, you need to give half calorie for ice and this thing. For solids and liquids, we use dq is equal to ms dt. For gases, we can use this, but it's not preferable. People like to use NCDT. T is temperature in Kelvin. Here C is your molar heat capacity, the amount of heat required per unit temperature per mole. This is what we use for gases. So we use, actually C and S are almost same. One is per mole and one is this thing, per gram or per kg. Take a break, come back by 7 o'clock. Any doubts so far? Anything, please ask me. Anything not clear so far? Clear? ठीक है, take a break, come back by 7 then.
सर
हाँ अनुषा.
सर फिर वो W इक्वल एक्चुअली क्या था
W?
जिस कोरिलेट W equals to JH and mechanical heat equivalent that taught us that equation like just equation लिखा दिया तो
W is equal to J वो.
हाँ
नहीं वो वही है ना. 1 joule is 4.2 1 calorie is 4.2 joules. This 4.2 joules is called mechanical equivalent of heat. Means 1 unit of heat is 4.2 times the unit of energy. That
okay
constant is called mechanical joule equivalent.
alright
बस वही था और कुछ नहीं था उसमें. That looks like very big something, कुछ तो है. Nothing.
okay thank you sir.
चलो, I'll be back in 5 minutes. Next thing. There's a bit of a theory. Then we define something called heat capacity. Symbol is H. So H is nothing but the amount of heat required per unit temperature, which is nothing but M into S or N into C. So when you go into a lab, right, and let's say there is somebody there, right, who will know what is the specific heat of that material? Right? Who will find the value of M to will be printed? Who will find the value of S and do everything? So what these people do, they directly print the value of H on top of it. Amount of heat required to change temperature by 1 unit. So example, this is how it looks. If you take a specific heat capacity S, this would be 200 example calorie per Celsius per gram. Same thing, if you talk about heat capacity of a body, units will be simply 400 calories per Celsius. So here we are talking about let's say per kg. So we are talking about 2 kgs ka body. Basically, you have multiplied the 2 kg with S. So specific heat capacity S is independent of mass because it is per unit. Whereas H depends on mass. So this is not any big concept there, but more of a practical thing. So when you go into a lab and you see a body there, it will be printed on top of it. H will be 300 calories per Celsius. Matlab, for that body, if you give 300 calories, temperature will be 1 Celsius. I don't care what is the mass of the body and anything else. So heat capacity is more of a practical thing in the lab. Then we define latent heat of fusion, LF. This is the amount of heat required to convert 1 gram solid to 1 gram liquid. So example, so this is how it would be. So dq would be m into LF. Example, latent rate of fusion of ice is 80 calorie per gram. So to melt 1 gram of ice, you need 80 calories. So now when some people heard about this, they came up with a very weird idea there. There's something called an ice diet. So for the afternoon lunch, you eat ice. For dinner, you eat ice. For breakfast, you eat ice. You will die. That's a different thing. But technically speaking, right? See what happens. First of all, when you eat something, you consume calories, but ice is something else. When you eat ice, first of all, it has no calories. It is pure water. But after eating ice, to convert 1 gram of ice, you need to burn 80 calories of your internal heat. Isn't it? Because once the ice goes into the tummy, which melts it is not the outside heat. It is the heat which is coming from your blood and from your body. And this is maybe not about ice, but it is actually one of the study people did when you're in a very cold environment, right? When you're taking a cold water bath, like one of the thing, early morning in winters, maybe 5 o'clock, people are just taking cold water baths. Being in a cold environment or a cold bath will burn a lot of calories. So now just think of it like this. Imagine you're eating 100 grams of ice. Right? So that would be 100 into 80. That would be like what? 8,000 calories. Yeah, that is like 8 kilocalories. Still not really that much actually. So if you eat 100 grams, you're just burning like what, 8 kilocalories. Meaning it's like a negative thing. First of all, you're not consuming anything. On top of it, you're burning more. So next time when you're eating ice cream, you can comfort yourself saying, I'm eating food which is burning calories also. Right? But problem with the ice cream is what you have too much sugar. So yeah. Same thing, we have latent heat of vaporization. People do a lot of weird things, or else how will you get attention in social media, right? That's the problem. Amount of heat to vaporize. One unit of liquid to gas. So here we're at Q is equal to M into LV. Latent of vaporization of water is 540 kilocalories per gram. This is actually a pretty huge value. 540 is a pretty big value. One of the reason why, if you see right on Earth, if imagine this value was 54, can you tell me what happens? Instead of 540, if the value had been 54, you know what happens on Earth's surface? Means water will vaporize 10 times more. So during daytime, the entire ocean space of water, 10 times more water will vaporize. So you'll have rainfalls much 10 times more intense. So next time imagine Mumbai ka rainfall 10 times more intense than normal. That one time only it looks like a hell. 10 times is like you'll have a floods, like literally. City would have been wiped out of the map. So one other thing. And second thing, do you ever think about it when there's a fire in a big building, you pour water, you know, what are you actually doing? Most people think water goes, cuts off the oxygen supply, that's why fire stops. That is bullshit. You're not putting enough water to, cut off the oxygen supply. What happens is, generally when there's burning, example, wood or something, wood has an ignition temperature of 800 degrees. That means if you, until unless the temperature rises to 800 degrees, the new wood will not catch fire. Getting it? Now, when you put a lot of water, the water starts absorbing all the heat from the surrounding and the temperature starts dropping down. When the temperature goes below 800 degrees, there is no new fire. So that way, water is quite useful. If you can dump enough water, that's a different story though. But it is mostly to decrease the surrounding temperature so that the new wood won't catch fire. Clear? Now, let's see, whenever you heat a solid or something, what exactly happens? So listen to this thing. This is theoretically a little important. So whenever you have a solid converting to liquid converting to a gas, we call this thing as a phase change. Let's say we have a solid. These are molecules vibrating. And let's say you started giving heat. Let's say heat is given at a constant rate, Q joules per second. So step one, what happens? As you're giving more and more heat to the body, the first thing, the temperature starts rising. It will be still solid only. So temperature rises. So kinetic energy of the system increases. Potential energy remains constant. Here potential energy is nothing but the bonds ka energy. Now, if you keep giving even more heat, and understand what is temperature? Temperature is a function of random kinetic energy. So if I give more heat, at this point, we have solid, but the bonds are also breaking. So now we have a solid and a liquid mixture. So in this process, temperature becomes constant. That is because kinetic energy becomes constant. Potential energy rises. So all the heat that is given is used to break the bonds. You're breaking bonds, that's why solid is becoming liquid. So you're actually increasing potential energy. Now, if you continue to increase, you'll become completely liquid. And if you continue to increase, liquid temperature rises. The molecules are moving more randomly, right? So again, kinetic energy increases, potential energy is constant. Now, if you continue to give more, you'll start seeing vaporization also. Meaning again, temperature becomes constant. Again, you're using all the energy to break the bonds between liquids to make it gas. Liquid bonds are broken. Correct? So that is the thing. So here they can ask an important question like this, a theoretical question. If heat is given to a body, should the temperature rise? General feeling is what if I give heat, the temperature will rise. There's no guarantee, right? During a phase change, temperature remains constant. Whenever solid is converting into liquid, during that time, all the energy that you're giving is going into potential and not kinetic. If heat is given to a system, temperature may or may not rise. So be careful with that. Because during a phase change, temperature won't increase even though you're giving heat. It is used to break bonds. During phase change, basically. This is what actually happens when you convert a solid into a liquid. It doesn't go directly to solid to gas or solid to liquid. Multiple things happen in the middle. Please have a look at this page. Now, if I try to put this on a graph, let's see how it looks. Let's do one problem. I think too much theory, you're getting bored. Let's say we have 100 grams of ice at minus 50 degrees. How much heat is required to vaporize this to 200 degrees steam? Get it, simple calculation, there's nothing there. Remember the value. Specific heat of water is 1 calorie per gram. Specific heat of ice and specific heat of steam is half. Latent heat of fusion is 80 calorie per gram. Latent heat of vaporization is 540 calories per gram. Let's get this. $79,500 calories. Okay, we have two answers with the same number. 79,500. Others, check your numbers. We have 84,500. We have 56,875. Some reason the 79,000 looks good. Someone got 74,000. Okay, we have two 84,000s. 1,500 chance in hai God. Here people are talking in thousands. 79,500. We have three 79,500s. Let's see. Check whether you did this thing right. So first you go from here to 0 degree ice. You're still in the ice only. You can't directly jump to something else. So since you're going from ice to ice here, this would be ms. So 100. S is half and change in temperature is 50. This is 2,500. Then from ice, you become 0 degree water. From 0 degree water to you become 100 degree water. From 100 degree water, say you become 100 degree steam. Then 100 degree steam, so you'll travel to 200 degree steam. This is the order. See if you skipped any step in the middle. You first have to, within the same state, you have to reach that melting point and boiling point, and then you have a phase change. Since you're going from ice to water, here it is Q is equal to MLF. So this is 100 into 80. So this is 8,000. This is again MS delta T. This is 100. S is 1 and 100. So this is 10,000. This guy is Q is MLV. This is 100 into 540. This guy is the biggest actually, 54,000. And here this guy would be 100. Again, S is half and again 100. How much is this? 5,000. So what's the total heat that required? Just add up all this. How much is this? 10,000, 18,000, 20,500, 25,500, 79,500. Check. Easy. So you directly can't jump from here to here. You have to go through each stage. So you have to be careful. Any doubts on this? Anyone not clear with any particular step here? Clear? Now, so all these steps that we did, we can plot a graph for this. This graph is important. So if you plot a graph for the temperature of the body versus time, and you're giving heat at a continuous constant rate. This is how the graph looks. So initially, you start with some temperature O, your temperature rises till A, then it becomes constant till B, again it rises, again it becomes constant, again it rises. So this is how it goes through. So initially O to A, you're in a complete solid. Then from A to B, it's a phase change. You're between solid and liquid. Then this is C and D and this is E. So B to C, you're completely liquid. C to D, you're in the phase change liquid gas, and after D, it is gas. Now, here few things. If you look at the line OA, dq is equal to ms dt. If you divide by time, dq by dt is ms rate of change of temperature dt by dt. dq by dt is anyway constant. So from here we get rate of change of temperature per unit time is proportional to 1 by ms. This is your slope, isn't it? That means the slope of the line OA is proportional to 1 by mass of the body and specific heat of the solid. Similarly, you take a slope of line BC, that will be proportional to 1 by mass into specific heat of liquid. So basically, higher the specific heat, lesser the slope. Obviously, right? Meaning we have more specific heat, it is more difficult to change the temperature. Similarly, when you look at AB line, AB is nothing but phase change. So there dq is m into L, right? So the length of the AB here, if the length is more, means there is more time taken. So length of AB means you have taken more time to melt completely. So this is proportional to latent heat of fusion. So if that line is bigger, means it takes more time to melt. So the longer line means it takes more time. If time is more, it takes more heat to melt. Similarly, length of CD is proportional to LF. Have a look at this. So examine, they'll ask a question like this. They'll give you graphs based on this, and they'll ask you who has more specific heat and who has more latent heat. Let me show you one. Any doubts on this page? Clear? Great. So tell me this answer. Let's say we have a temperature versus time graph. Let's say this is liquid 1, substance 1. This is material 2. So compare for solid, specific heat S1, S2, who is bigger, who is smaller. Then latent heat of fusion, LF1, LF2. Then for liquid, whose specific heat is more. Then L vaporization of 2. And then for gaseous state, whose specific heat is more. So there are two graphs, material 1 and 2. From the graph, you have to tell me who has more specific heat of solid, liquid, gas, and latent heat. Try. Remember this thing, we just wrote it here. The slope tells you is inversely proportional to specific heat and the length is proportional to latent heats. That's the main idea there. Clear? What is the answer? First one. Who has more slope? The red or the green one initially? Red one has more slope, so S2 must be greater. The slope is proportional to 1 by S. The more slope, less specific heat capacity. Then between S1, S2, maybe if I name them now, you will get it, I guess. O, A, B. Between BC, who has more slope? Green has more slope. This guy. This guy. LF1, who has more length. The red one has more length. Your green one has more length. Check. Thus, you just need to see the slopes and the lengths and you're done. Clear? Any doubts on this? All got this? Next thing. We're almost done with the theory. Water equivalent. What is water equivalent? So generally what happens in a lab, most of the time people do all experiments with respect to water. So if you're boiling water in a copper pipe or a copper container, it's like, people are irritated, like who will find the values of copper separately and then water separately and then add all. So what people did, we replace that, if you want to replace it copper container with some water. So the amount of water which has the same change in temperature as the body for same amount of heat. So if you can replace that entire container with some water, your life becomes more easy. Calculations are easy. So example, let's say we have a vessel. So on the copper vessel, it will be written, this is 100 grams water equivalent. That means if you take 100 grams of water in this copper vessel, they both are exactly same. If you give them some heat, the temperature change will be exactly same. So we can replace this vessel with 100 gram water. Example. So now in this vessel, someone puts 250 gram water. And let's say this is 100 gram water equivalent. You can just replace this whole thing with 350 gram water and solve the problem. Clear? That's it. Water equivalent meaning you can replace that container with an equivalent amount of water, which will produce the same change in temperature. So now the whole thing is in terms of water, so it is more easy to solve. Again, this is also mostly for the purpose of labs only, to keep it things simple. It's not a concept. Principle of calorimetry, it is another form of conservation of energy. So heat lost by the bodies is equal to heat gained by the other bodies. There, that is all the theory that we have in calorimetry. Let's see some numericals now. Can I go ahead? Any doubts on this page? Rehan? Clear, na? Swastika? Neil? Anika? So far clear? Let's see a question. Why is this lagging? We'll keep this question dry. Let- oh. So let's start with this. We have equal masses of three liquids ABC. Temperature is 10, 25, and 40. When A and B are mixed, temperature became 15. When B and C are mixed, temperature became 30. So if A and C are mixed, what is the new temperature? So we are just using this concept. Heat lost by one body is equal to heat gained by other. So you're mixing A and B, temperature became 15. A ka temperature was 10, B was 25, but when you mix, you got only 15. Now that means what? They're equal masses, huh? Specific heats are not same. Try. I'll give you a minute or two. Any answers? Okay, we have one answer. And that might be right. One answer. Lakshika got 16. Aryan God, how the hell did you even get that? So I'll punch you know. यहाँ पे numbers are starting from 10, 25, 40. When you add them, how did your temperature decrease? Ah, Yasha, you also got the same 16. Lakshika got 16. You might be right. Let's see how to do. Gods, if you mix a 10-degree liquid and a 20-degree liquid, you can't get 5-degree liquid. If you have got something like that, we need you. The humanity needs you. We can put you in a cryo chamber and we can create energy out of nothing again from this. So maybe must have messed up some calculations. Check it out. Let's see. So first let's talk about A and B. So mass of A is same. Specific heat of A, let temperature has become how much? 15. So 15 minus 10. So this is the heat gained by A. This is the heat gained by A. This is mass SP, and this is 25 minus 15. This is the heat lost by B. So that would be SA is equal to 2SP. This is one equation we have. Same thing I'll do for B and C. M, SB. Now temperature has become 30. So 30 minus 25. So B is gaining this time. M into SC. This guy is 40 to 30. Now this guy is losing. So we have SP is 2 times SC. Perfect. I want to do for A and C. MSA, let the final temperature be T. So A will gain, obviously, because its temperature is less. And C will lose here. So this will be 40 minus T. So just be careful with the signs. And from equation 1 and 2, we can clearly see SA would be how much? SA is 2SB. T minus 10 and SC is SD by 2, 40 minus T. SB cancels. We end up with 40 minus 40 is equal to 40 minus T. So 5T is equal to 80 and T is equal to 16 degrees. Check. Clear? The specific heats are not same. See where you messed up the calculations. Easy one, but yeah, it's a good one. Next one. Any doubts on this page, please ask me. Next thing. Let's say we have n different liquids. Of mass m1 M2, so on till Mn. Specific heat capacities. S1, S2, so on till Sn. Right? Temperature. T1, T2, so on till Tn. You mix all of them. What is the final temperature? How do you do this thing? N different liquids with different heats, different temperatures. Everything is different.
फिर ऑर्डर नहीं दिया क्या किसका क्या जरूरत है
They're increasing or decreasing?
Which one?
Like
M1, M2, Mn, S1, S2, Sn, T1, T2, Tn. Bus. What do you need? What do you need in this? I don't know what are those values. We don't know. Anything can be anything, right? So here the problem you're getting confused is like who is losing heat and who is gaining heat. We don't know. Then don't do that. Na? Assume all are losing heat. Can all of them lose heat? No. So let the final temperature be T and let all of them lose heat, but the net heat lost is 0. The science will take care of it. When you don't know who is losing and who is gaining, you just assume everyone is gaining heat. That is the best thing. And then let the science take care of it. You don't get into that. I would have done that. So I'll assume all are gaining heat and I will just write the equation. The values will take care. Get it? You get a good answer actually. Let's see. Yeah. So let all gain heat. Let final temperature be T. And let all gain heat. That is not possible. So something will become negative. So first guy will be M1, S1, T final minus T1 plus M2, S2, T final minus T2. So on till Mn, Sn, T final minus Tn. This is a net heat gained, which is 0. So if you just remove the T final from there, you will end up with sigma mi subscript si Ti by sigma mi si. There, that's your good answer. So when you actually calculate this, you will find this T final will be actually less than some of the temperatures. So those will be negative signs in the middle. So that will take care of it. So that you need not worry who is what. Clear?
This is under the assumption that none of the liquids are vaporizing, right?
We are assuming it's in the liquid form only. There is no
Okay.
phase change as such. Clear? We have a rod here. Mass M, length L, alpha, specific heat. Heat Q is given. Assume all the heat is absorbed by the rod. Find change in temperature. So this rod is placed on a smooth ground. And you give heat Q to this rod. Find the change in temperature.
So
Okay.
can you do the previous one for us, actually?
Hmm.
Yes, sir, thank you.
What's the catch? Normally, what is QMS delta T, na? So what is the catch? If the temperature rises, what will happen to the length? Increase. So this rod which is here will become something like this. That means this rod ka center of mass actually goes up. So the center of mass rises by a height of L by 2 alpha delta T. This is the change in height of center of mass. So where did this rod got this energy from? So the heat supplied will be ms delta T to change the temperature plus mg delta center of mass, change in potential energy. Because the height of the rod is increasing now, that energy should come from somewhere. So this would be ms delta T plus mg L by 2 alpha delta T. So the change in temperature, all the energy, heat energy didn't go into the rod for temperature. Some of this went into increasing the gravitational potential energy. Make sense? So that means if you have a rod on the floor and if you have a rod vertically, this guy will have less temperature. Isn't it? Because this thing will expand horizontally, na? Center mass won't change much. But when you keep it vertically, center mass will change more. This could be a good theoretical question. Clear? If you think your mechanics leaves you, you are under an illusion. Next one. Understood the concept now? What happened here? Why all the heat didn't go into the rod? Because when the temperature changes, rod will expand. If the rod expands, center mass will go up. That means some energy from the heat went into increasing the gravitational potential energy. Let's say we have a rod with a spring. The rod with a spring. K1, K2. The spring ka length is L. Alpha. This is placed on a smooth ground. Springs are in natural length. So someone gave heat Q to the rod. Find change in temperature of the rod. Compression in the springs. Now in this process, right, actually the rod also will have some energy stored. We will ignore that. For that, we need something called Young's modulus and all. We'll not get into it right now. Assume no energy stored in the rod due to tension. Let's get this. Equilibrium. So after giving heat, system comes to an equilibrium state. So find the compression in the springs and change in temperature of the rod. Get me the equations. Solving all variables, that will be bad. There, this is how you can combine mechanics with calorimetry with thermal expansion. Just get me the equations. Rod here. So what is the catch?
So the specific heat of the rod is not given.
हाँ वो भी चाहिए तुझे. मास भी चाहिए. Q is MSDT minus K1. नहीं अनिका, that's a blunder. Why did you assume both the springs will have same compression? किसने बोला springs का compression same है? Draw an FPD. Try. It's a good one. I'll give you a minute. It's not a tough one. It's a different one. Of KX1 MSDT. Okay, and okay, but still you're short of one equation, right, Lakshika? Let's see. That is right. You got that, Lakshika. Anusha, you are also missing one equation. No, you also got it right. Anusha, Lakshika, both of you got it. Let's see. First thing. Let this guy expand x1. Let this guy expand x2. And the rod ka length will become L into 1 plus alpha delta T. So that means x1 plus x2, the compressions, will be equal to the change in length of the rod. Agreed? Whatever the rod expands, that should be the total compression in both the springs. This spring is pushing with K2 x2, this spring is pushing with K1 x1. Since the rod is in equilibrium, K1 x1 is also equal to K2 x2. Fourth equations. And then third, energy conservation. So heat supplied is going for ms delta T to change the temperature plus half K1 x1 square plus half K2 x2 square. So the energy goes into two springs, N plus ms delta T. Done. Three equations, three unknowns. The total change in length of the rod is the compression in the springs. Spring forces are equal because the tension should be same. It is in equilibrium. And whatever energy you supply will go into the rod and plus the springs.
So, but यहाँ से कैसे eliminate करूँ?
Come again.
Like how will you eliminate the variables now?
Why can't you eliminate?
Like But I wasn't able to, like, how, what will you
Think
do?
about it. You guys are super max students. You can't ask such questions. It's see how many variables are there? 1, 2, 3.
Both
Agreed?
the two equations, two variables, but like,
So ho gaya na, then done. As a physics teacher, my responsibility is done. You should go and ask your math teacher about it. He'll punch you right and left. देखो ना, here we get x1 by x2 का ratio k2 by k1 ना. So from here you'll get x1, x2 separately.
acha, okay.
And then dump it in this na.
Yeah.
You guys understand all weird questions I teach you. When it comes to solving, you suddenly get a problem. Next one. Last one for the day. Easy one. Specific heat S is given by AT cube. S is not constant basically. A is constant, T is temperature in Kelvin. Mass is M. Find heat required to change the temperature. Hundred to 200 degrees. Get this. Chalo, you guys didn't fall into the trap. So Q is what? When variable M is dt. Just be careful with the limits. 373 to 473. 100 and 200 looks good. ठीक है? ठीक है. That's the last one for the day. So next class when we meet, right, we are going to do problems based on, ice and water. If you mix the what will happen. So we will include phase changes now. Till now we didn't do any phase change problems. So it's not much. There are like 2 to 3 models on that. And then we'll start off with kinetic theory of gases. So like calorimetry is a small one. KTG is again mostly like your ideal gas equations, but then again, even in that we'll have some springs and pistons and stuff. So it'll be fun. Okay, so with that, we'll wrap up for the day. And the rotation test will be online mostly tonight or tomorrow morning. I'll try to keep it online tonight only. So do give it, getting it, and okay. So start doing it. I hope everyone has finished rotation ka solving. If there is anything pending, do finish it off. Chapter is very good chapter. It's a very high weightage. So that chapter has to be strong. ऐसा मत सोचा रे major test हो गया था, will we can ignore it now. So do finish it off at least by next Wednesday. Keep a deadline. Rotation ka whatever is the pending, finish it off. That is the reason I kept test on rotation again. And then we can start off with thermal expansion, calorimetry. You can start solving on this stuff. On these things, I'll send you a sheet because the questions are a little scattered everywhere on these things. I'll try to send you questions specifically on thermal expansion and calorimetry and separately. Okay, with that, we'll wrap up for the day. So any doubts, anything, please stay back and ask. Also free to leave. So take care, stay safe. I'll see you.